So today we're going to start the practices of igneous rocks. Okay, as you may know, igneous rocks come from the cooling of a magma. The cooling of a magma can be produced at different rates of temperature and pressure. So in this small drawing you can see the different situations, very simplified. But when we have a magma which is placed at depth, at high depth in the Earth's crust, we have high pressures, high temperature, and then this magma will be cooled in a very easy way, very calm way. Then we have the formation of Plutonic rocks. Plutonic rocks, which are defined by what we call the phaneritic texture. Phaneritic texture means that I am able to see individual crystals with naked eye, right? The texture is always crystalline, and the rocks are formed always by minerals. So we have phaneritic texture, crystalline texture, that means full contact between the grains. The grains are coarse. That means that when I take a look to the rock, I can clearly see any individual grain, right? So this is a phaneritic texture. And of course, as this crystalline texture composed by minerals at high depth, high temperature, high pressure, we won't have any type of void, we won't have porosity, right? Okay, this is when I can crystallize my magma at high depth. But the opposite is that I have the possibility that my magma voyages through the crust and achieves the surface or close to the surface. In this case, we are talking about explosive or volcanic rocks. Okay? In this situation, I can have an eruption, and then I have a flow of magma with gas and through.
Lo siento.
No pasa nada. Continuemos. Okay. We have the magma that is expelled through the surface with gas. And then in these cases we will have the formation of pyroclast. That means there are drops of magma which are solidified in the air, and I will see one special type of texture which is what we call a lava, which is full of bubbles, okay, vesicles, okay, from the statement of gas. Okay. Another situation is that once this magma is disgasified, I will start to have one lava flow, una colada lava. In this case, I will have rock, which is a lava flow, which is very fine grained. In this situation of very low temperature and very low pressure, we don't have enough time to crystallize and form new minerals. So usually what I will see is a dark rock with no minerals or only some dispersed minerals inside. Okay? Which is this situation. For explosive or volcanic rocks, my types of rock will present what we call an aphanitic texture. That means that my grains are below 0.1 millimeters, so I cannot identify them with naked eye. Usually, most of the rock is composed by volcanic glass. Okay? That means that this magma hasn't had enough time to form minerals, to form crystals. So it's just this unorganized internal structure. We also can see some dispersed minerals inside. Okay? And the most important thing is that I can see porosity or vesicles. That means these holes which are related with the escapement of gas. Okay? In some cases, they are very evident. In some other cases, they are more smaller. Okay? But I have to take a look to them. Okay? In the middle, we have a situation that we have the hypabyssal rocks. They are not plutonic, they are not volcanic. So, in this situation, we have halfway conditions of halfway textures. One of the most typical textures for high abyssal rock is what we call a porphyritic texture. And if you remember from the previous class, we have a bimodal distribution. We have in this graph where we have frequency and the other hand we have size. We have one fine-grained matrix with some mineral, some visible minerals. Okay. For example, in this situation, okay, do you see these grains? Okay, and in the middle there is a very fine-grained matrix. Okay, this is what we call a porphyritic texture, and this is very typical of hypabyssal rock. Okay? In other situations, what it happens is that I don't have enough time to form big crystals, so I will have just a fine-grained rock where I can see small minerals, not that small like this, okay, but small minerals, usually composed by feldspar. And this is the type of rock that we call applied. Okay? The rocks that we'll see today is granite, cyanide, and gabbro, which are representative of plutonic rocks. You also will see basalt and basaltic lava, which are representative of volcanic rocks. And then we will see three types of hypabyssal rocks, which are porphyritic granite, applied, and pegmatite. Okay? We will classify them according to two criteria. One is the texture. I don't see the grain size, it's very fine grain. I can see the grain size, and I have, in this case, this special type of texture, which is porphyritic granite, or I see small grains, or in this case, very big grains, but it's not something regular like in this case. Okay? So this is the textural criteria, and the other are the minerals. And these are the minerals that we have to learn to identify. Okay? The most easy and the most important is quartz. Quartz, as you know, is pure silica, usually is the last mineral to crystallize. So usually we won't see nice regular shapes, but what we'll see is irregular shapes. Always with a vitreous luster, because quartz is a very stable mineral that doesn't use to weather. So something that is irregular shape with vitreous luster, usually the color tends to be about gray. It shows no cleavage, so it breaks like a glass. And it's very hard. This is the criteria for identifying quartz. And in all of your rocks you have samples of quartz. Okay? You can try to scratch it with your knife and you'll see that you can't. Okay? Another very common mineral are feldspars. Feldspars crystallize before quartz and they can develop very nice or well developed crystals. Sometimes they are irregular as well, but usually you will be able to see these nice shapes. The luster is quite variable. It can go to vitreous when fresh, most of the times, but sometimes it can show some dull, some earthy luster. Okay? The important thing in feldspars is that they show cleavage. So when I examine a rock that has feldspars, under the light I will be able to see these repetitive planes through that the mineral is broken, and we call them cleavage. Right? The hardness is quite high and lower than quartz. And we have two main types, the plagioclase and the orthoclase. Okay? In general, the orthoclase, which is called, also called potassium feldspar, it's used to be pinkish or reddish or orange. For example, like this. Okay? This is usually the color of the orthoclase or potassium feldspar. This is not always like this, but for you that will work. When you see whites, greys, greenish colors, then we will be talking about chrysoclase, okay? These are the criteria for distinguishing between them with and this one, okay? If not, we should use the microscope, but we don't have this here, okay? Then we have crystals of micas. Micas, which can be biotite or muscovite. They are very distinctive. Usually they tend to show this hexagonal regular shape, okay? With a perfect cleavage. Perfect cleavage which just reflect in a perluster. In this case, muscovite, we will see this perfect cleavage that reflects perfectly the light. Reflects perfectly the light, okay? When we see this mineral and is white, we call them muscovite. If it's black, we call it biotite. For example, in granite, these black minerals that reflect the light so well, those minerals are biotites, right? Another type of minerals that we'll see, which are quite similar, are pyroxenes and amphiboles. Usually are black and show some vitreous luster and prismatic shapes. Okay? If you're lucky and you see the basal shape of the crystal, usually pyroxenes is like a square, and amphiboles is like a rhomb which is trimmed at the edges. Okay? But this is a little bit difficult to see. But the important thing is not to misconfuse between these two and biotite. Pyroxenes and amphiboles show this vitreous luster, they are prismatic, and biotite always has this perfect cleavage, this pearly luster, and shows this hexagonal shape. Okay? And finally, in some volcanic rocks you will see olivine. Olivine, which is very similar to quartz, is irregular, shows a vitreous luster, shows no cleavage, but is green. Okay? And okay, this is, sometimes you will see like big chunks inside of a piece of lava, or sometimes like small crystals. Okay, it's like a piece of a beer bottle which has been broken. Okay, so it resembles like that. So these are the minerals, and finally, the minerals are used for classifying the rock. Granite. Granite is a plutonic rock, means coarse grain, that always has the presence of quartz plus feldspars. And these two are the essential minerals. Okay? Most of the times, granite also has biotite or muscovite or other minerals. But the very important minerals for saying the name of the rock of a granite is the presence of quartz and feldspar. Right? Another different rock is cyanide. Cyanide is very similar to granite, but we don't have quartz. So if you see a rock that is mainly composed by feldspars, like this one, but you don't see quartz, this is a cyanide, right? And another type of rock is a gabbro, which doesn't have quartz at all, and it's composed by pyroxenes plus feldspar. And usually this is a black rock of high density, where we can see grains just composed by grains of black and sometimes white minerals, okay, but mostly black, which are these pyroxiles. Okay, this is the gabbro. The basaltic lava, we have already discussed about that. Basalt. Okay, the porphyritic granite. We will see a porphyritic texture, and we have the composition of a granite, which is quartz plus feldspars. Okay, so this is a porphyritic granite. Then we have one applied. Applied. A rock which is composed mainly by potassium feldspar, where you can see very small grains. You don't have this coarse grain of a granite. Okay, so this is an applied. And finally, this is a special type of rock that we call pegmatite. Okay, that we usually show these very big crystals. Okay, here we'll see it's not a very important rock in order to that you will see this rock in a lot of places, but it's a good rock to practice and identify minerals. But because here you will see perfectly the crystals of muscovite, quartz, and feldspars, right? So these are your rocks. So that's it.